All right, let's get started. All right. Good, thank you. All right, so here is your ellipse. There is a lot to look at with the ellipse, okay? So yesterday we did circle and parabola. They were kind of the introductory conic sections, and this one is, again, there's a lot going on here. So the general structure of the ellipse, number one, it can be, I call it horizontal, like it's wide in the horizontal direction, like on the left. And then you can have one that's vertical, it's wider in the vertical direction. And so you have a few key features I want you to look at. So here are the centers. And then the long, we call this an axis here in blue. The long axis is called the major axis. And just like always, we're super creative here in the math department. And the short axis is called the minor axis. These are in purple. Okay. All right, so these are just the basic kind of structures. So you have the major axis, the minor axis, you have the center, then these familiar structures that we keep seeing, we have two vertices. And notice the vertices are at the ends of the major axis, right? They're like on the long ends. And now we have a new vocabulary word. We have something called a covertex, which these are vertices along the short axis or the minor axis. So you have a covertex. You have two vertices. And then just like we've seen before, we actually have the focus. And we have two of them again. This one is the foci. So foci is the plural of focus. We have two of those. They are floating inside of the ellipse, right? So these things move around back and forth. The good news is looking at some of these things that are labeled, the center is still H comma K, which is great. That's what it's always been, okay? And then you have your two formulas. So notice there is a formula for the horizontal major axis, which is slightly different than the formula for the vertical major axis. And I'm going to highlight the difference for you. The difference is where A and B are located in the equation. Everything else is the same. Notice in the horizontal, it's under, A is under the X. And in the vertical, A is under the Y. A is bigger than B. And the reason for that is because A is the distance from the center to the vertex. So that's always going to be larger, right? If it's stretched horizontally out this way, it's going to be longer from the center to the vertex than from the center to the covertex. And so, like I said, lots going on with the ellipse. And we'll come back and examine the hyperbola in just a minute. Let's take a look at example number 1. There are a lot of examples today. I apologize in advance. But it's just necessary because there's so much going on. I don't want to just throw it at you all at once. So the first thing we want to do, just like we did yesterday, is we want to rewrite this in the appropriate form. And the first thing you've got to do is you've got to figure out, is this a horizontal or a vertical ellipse? So I want you to look at the two equations below, and let's take a look. Remember, A is bigger than B. So this one's going to be, A is under the X. So that's actually going to be a horizontal one. So it's going to be kind of like this, right? So let's rewrite this in the correct format. This would be X minus 2 over 5 squared plus Y minus 5 squared over 2 squared. Now, why am I rewriting these denominators as numbers squared?
Because that's how it is in the formula.
Yeah, that's how it is in the formula. And we are just duplicating what is happening inside of the formula. Okay. So in this case, looking at your formula, what is H?
-2.
Positive 2. There you go. And what is K? 5. So that was pretty easy, right? Center's 2, 5. Go ahead and enter that in Delta Math so you can get that right. Yeehaw. So remember the center is H and K always. And that's kind of, the same as yesterday. All right, now let's go down. And this asks me to find the vertices of this ellipse. So again, step number 1 is I'm going to rewrite this, bless you, just like I see it in the formula. So we're going to take some time and do that real quick. Over 9 would be 3 squared equals
Is
1.
up and down?
Would it?
No. Yes. No,
So-
just-
Which is the larger number, 5 or 3? And remember, A is always bigger than B. So it looks like this one is going to, again, be kind of situated like this. Like this, right? All right, so we've got this transformed into what we are looking at on our formula sheet. So now we can identify some things. So the first thing I want to kind of sketch out here is my center, which in this case is -4, -4. And then I can also pull out values for A and B. So what is A? 5. And what is B? 3. All right. Well, that's good news because if you go back, if you remember the vertices, if you look at your ellipse on the left, you have a center and then the vertices are here on the edges. These right here are the vertices, and that's what we're looking for. Looking at your diagram, what does it label as the distance from the center to the vertex? A. So basically the vertex plus or minus A is going to give, the center. I was thinking ahead of myself. The center plus or minus A is going to give me the location of the vertices. This is a nice note to make. The center plus or minus A. Well, that's good news because I have the center and I have A. So you know how I like to make sketches here. And the basics of what I'm sketching, this is the center located at -4, -4. And then I have a vertex to the left and a vertex to the right. How do I know that? Because it's horizontal. We just talked about that right here. And I know that this distance right here is A units, which is 5. It's going to be 5 this way. And so it's going to be 5 this way. So if I am moving these points horizontally, what is changing, X or Y? It'll be X. So the new X would be -4. And I'm going left, so I'll subtract 5. That's -9, -4. And if I move 5 units to the right, that'll be 1. Yeah, plus 5, exactly. So this will be plus 5 units, this will be minus 5 units, and so you'll end up with the coordinates of the vertices exactly as these. So you have 2 coordinates for vertices. So this one will be -9, -4. This will be +1, -4. So you really kind of have to, number one, you have to be able to manipulate the equation to get it to look like you want, so that you can then pull out this key information. Then using the formula, you have to determine, am I vertically oriented or horizontally? And then you're able to figure out, because if we were vertically oriented, we would be adding this 5 to the y coordinates because we would be moving vertically to get to the vertices. Right? So you have to understand how they're oriented, what the relationship is. There's a lot going on. Questions about this one? All right, let's go again. So this one says find the co-vertices of the ellipse defined by this equation. So step number one for me is always going to be to rewrite this in the form that I need it so I can see it clearly and pull out all of my key information. So this would be 3 squared equals 1. Basically what you're going to need when you're working with these, remember how we needed center and radius. Well, now in the ellipse, we're going to need the center in A and B because everything kind of builds off that. So the center here is going to be -2, -2. And then I have A, yes ma'am.
I think that one's supposed to be 4 on the first one. According to the 2.
It is, thank you. I don't know why I did that. Thank you for catching it. It is. There we go. So this would also change to -4 and -2. All right, so is this a vertically oriented ellipse or horizontally oriented? It is vertically oriented. So, I'm going to have this ellipse. It's going to kind of look like this. I'm going to have some center. These would be the vertices, but it is asking me for the co-vertices. So these are along the short line, right? So these are the co-vertices. They are along the short axis, the minor axis. And now let's take a look. If you look on your diagram, what number is going to define the distance between the center and the co-vertices? Right. What letter? B. So that's B units. So this is the center plus or minus B. So B in this case would be 2 and A would be 3 because of these numbers. And then I like to draw, again, if you don't need this little diagram, then you do not have to use it, but I like to use it. That's the center. And then I've got a co-vertex here and a co-vertex here. This distance is going to be 2, and this distance is going to be 2. I have a center of -4, -2. So if I'm moving 2 units horizontally, what is changing, X or Y? Right. So this would actually be -6, -2, and this would be -2, -2. Because all I'm changing, I just moved 2 units to the left and 2 units to the right from the center. And that gives us our co-vertices. So this will be -6, -2, and -2, -2. Questions about co-vertices? Bless you. All right. More vocabulary. This one asks me to find the length of the axes. There are 2. Remember, there's a major and a minor. Let's rewrite this in its appropriate form. So this would be x minus 5 squared over 2 squared plus y minus -5 squared over 5 squared. And this is always equal to 1, always. So number 1, is this vertically or horizontally oriented? Yeah, this one looks like this, right? This one is tall. And so this is A and this is B. All right, so let's take a look at the diagram again. So remember, the long axis is the major axis, and we said that these lengths are which, A or B? A, along the major axis, and along the minor axis, what are these lengths? Say it again. B. Okay, so if this length is A, so is this one. what is the length of the major axis here? Let me draw it out for you a little simpler.
Is it 10?
It's going to be 10. So if I have this center here, and then I've got co-vertices, so this is B, and this is B, and then I have vertices and another vertex here, and this is A, and this is A. This is the length of the major axis. So it's A plus A. So this will be 10. And so then what would the length of my minor axis be? Here we go, it'll be 4. Because that's just B plus B. This is B plus B. And the length of the major is A plus A, because you can see on your diagram from center to vertex is A, so we just double it to get the full length of the axis. And this is length of the axes, both minor and major. This one's actually pretty easy. I like the length of the axis ones. All right. Next one is concerning the foci of the ellipse. The foci of the ellipse. And so let's do, due diligence over here first. Let's rewrite this. This would be 5 squared plus y minus negative 1 squared over 2 squared. All right. Vertical or horizontally situated? Horizontally. So, at this point, I just go ahead and start doing stuff like this, right? So I've got, these are the basics of the ellipse. You have a center, co-vertices on the short, vertices on the long, and then you have an additional structure, which is what we're actually looking at now, and these in blue are the foci. Okay? I'm just going to abbreviate that F. This is F. These are the foci. So looking at your diagram, what letter describes the distance from the center to the foci? C. So this is C units. Let me do that in a different color. This is C. And then you also are given the formula for C. The formula for C is C squared equals A squared minus B squared. So what two things do I need in order to find C, according to the formula? A and B. So what's A? 5. What's B? 2. So C would be equal to the square root of A squared minus B squared. And you're going to get, when you're doing this, you're going to possibly get some irrational numbers. And that's cool. 5 squared minus 2 squared, that would be the square root of 21. The square root of 21. So actually, this distance C is the square root of 21. Well, how do we find the coordinates of these foci? Well, I need the center, and then I know I have the foci here and here, right? This is the foci, and then this is the center. So the center is located at where? That'd be 5, negative 1 from H and K. Agree? Yeah? Okay, so that would then be, if we're going to the left, we would subtract root 21 as a distance. If you're going to the right, you would add it. Are we going to add it to the X or the Y? X, because we're moving horizontally. So here we would, subtract. So I'm going to do that. I'm going to say, okay, I've got 5 minus root 21. And then on this side, I would do 5 plus root 21 because we're moving in the positive direction, not the negative. All right, let's round to the nearest tenth because that's what it asks us to do. So I'm moving from 5 minus the square root of 21. That gives you something crazy, but we'll give you 0.4. So this coordinate is 0.4, comma, -1. And then we'll do 5 plus root 21, which will give me 9.6. So this coordinate will be 9.6, comma, -1. And these are the coordinates of the foci. There we go. So it would be 0.4, -1. This would be 9.6, negative. Aren't you glad you don't have to memorize all of these? Okay. All right, we're going to graph one of these. So the first step is we need to rewrite it. X minus 6 squared over 2 squared plus, this would be y minus 0 squared over 5 squared. And then remember I told you there are a couple of important things that we need in order to graph an ellipse. Well, number one, I need to know whether this is vertically or horizontally situated. It's going to be vertical, right? So it's going to kind of look like this. And then I need a center, which is at 6, 0. And then I need A and B. What is A? What's A? 5. What's B? All right, so remember, if I'm sketching this out, this is the half of the major axis, so this is going to be 5 units. B is the length, or half the length of the minor axis, so this is going to be 2 units. So if you look at what delta is asking you to do, it's asking you to move that center around, which would be at 6, 0. And then that means if A is 5, that means you're going to go up 5, down 5. You're just going to stretch those vertices to those locations. And then your co-vertices are 2 away on either side. So you should be able to stretch and create the ellipse. So make sure you can do that. Make sure you have a length of 5 right here along the major axis and a length of 2 along the minor, and make sure your center is in the correct location, and you should be good to go for graphing it. It doesn't require you to do anything with the foci when you're graphing these. All right. Let's do one more. All right, let's rewrite it. This will be x minus -2 squared over 8 squared plus y minus -4 squared over 5 squared. Vertical or horizontal? This one's going to be horizontal. It's going to be like this. So you're going to have a length here, which is going to be A, because it's bigger. Then you're going to have this short length B, because it's smaller. So this should be 5 units. This should be 8 units. And then your center is located at -2, -4. So you'll just graph the center, and then you'll pull your vertices and co-vertices these lengths away. This one would be down here at -2, -4. And we said 8 units this way, so it'd be 2 units, then 6 more. This would be -2 to -10, be 8 units. I don't know what B is. B is 5, so this would be right there. And -4 to so you'll kind of end up with something like this, stretched around in delta. The graphing's easy in Delta. I like it. I feel like it's much easier than graphing it on paper, and it gets the job done. So, I think I'm going to take a break after the ellipse notes before we start the hyperbola. And I'm going to let you work a little on those sections in Delta that actually, no, it's all mixed together. Dang it. Oh well, we'll do hyperbola notes. All right, let's graph a couple of these, or actually write the equation from the graph. All right, write the equation for this conic section. What type of conic section is this? It's an ellipse. It's vertically oriented, right? So you should probably write the general version of the vertically oriented ellipse equation so we can just start plugging things in. So this is x minus h squared over b squared plus y minus k squared over a squared equals 1. And so remember, all we need is a center, hk, we need a b, and we need an a. And if we can get those three things from this graph, then we're golden. All right, so remember b is the distance, or half the distance of the minor axis. hk is the center, and a is the length of the major axis cut in half. All right, so what's h and k? What is the center? -3, -3. And then what is the length of the minor axis cut in half?
4.
4. And so what is a? 7. All right, so let's just plug all this in. This will be x minus -3, so that'll be plus 3, over 4 squared, which is 16, plus y minus -3, which will be plus 3 squared, over 7 squared, which is 49, equals 1.
Will we ever do anything with the 1 at the end?
No, this just is always 1. It's always that. It's always that. All right, we'll do one more of those. I'll let y'all get that one in there. Questions so far? It's really just knowing what the structures are and what to name them, and then they just plug in the formula.
It says it was wrong. You got it. And then oh, 7 squared.
Let's say it is. Oh, it wants it as the squared version. That's
No, it's as
stupid.
the equals. No, you put the equals 1.
Y'all didn't put the equals 1
I got
at the
that
end?
one wrong. No.
Oh, okay. You gotta put that. That's okay.
Please don't.
What do we gotta do?
Keep the 16 and 49.
Oh yeah, this is the full equation. That equals 1's got to be there.
Wow.
Okay, good. We know now. Fantastic. All right, let's do this one. This one is horizontally oriented, so it's going to be slightly different. This will be x minus h. I'm glad you figured it out now instead of later. So this will be a on bottom plus y minus k squared over b squared equals 1. We've got a center of 5, 4. What's a? 5. That's your major axis. What's b? 3. Very good. So we'll write x minus 5 squared over 25 plus y minus 3 all squared over 9 equals 1. I feel like the graphs are always easier.
Wouldn't it be y minus 4?
Is it 4? My bad.
Yeah.
I pulled that B from there. Thank you. I don't know what's going on here. Nice. H and K, A and B, and all that. All right. That is the ellipse, and all we got left is the hyperbola. The hyperbola, oh, it hurts. It hurts my head. Because everything is kind of backwards.
From this that we're doing now?
Yeah.
Why would we go to the same day?
Because y'all are capable of doing that.
Y'all that.
Oh,
Yeah, we only have like 45 minutes on the
There's too many lines.
All right. Hyperbola. So take a look at your formula sheet. I want to point some things out to you. You might want to annotate some things just so you know what I'm talking about. Okay, so notice this kind of looks like the parabola. It also kind of looks like you took an ellipse, cut it in half, and bowed the ends out. You can see that. Like you took it. So the good news is we pretty much got all of the same vocabulary. Let's talk about opening up and down versus left and right again, okay? This is the one that opens up and down. Because these little half parabolas are up, down. This one is the left, right open. I'm pretty good at memorizing all of the others, but I'm bad at memorizing this one. I have to look a lot at my formula sheet with this one because my brain wants to reverse these two for some reason. So if we're looking, and if you're, whatever method you find that works to remember, or you can just look at the formula sheet. So what is the difference between the two formulas here? A and B stay in the same location.
H, no, the Y.
Yeah, these flip flop. And we have subtraction instead of addition, right? So the order matters. A is still always first. A is still the distance from the center to the vertex, okay? A is still distance from center to vertex. And let's look at where the vertexes are, vertices. They are exactly where you'd expect them to be on like a parabola, right? They are at these extreme locations here and here, vertex, 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 vertex. Then you also have the co-vertices that we saw in the ellipse. Co-vertex, 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 except they're kind of floating, right? They kind of float out here. B is still the distance from the center to the co-vertices. But now, instead of necessarily being bigger or smaller, A just is the one that's first. So you see what I mean? Where you're like, the ellipse is pretty intuitive for me. This one hurts my head, like I said. This one comes first. This one comes first. And then these things are switching locations. What comes first determines the up, down, left, right. When Y comes first, it's up, down. When X comes first, it's left, right. Which is, maybe makes perfect sense to you. Does not make perfect sense to me. It hurts my head. I don't know.
Because y is the values up and down of the line. So
It makes sense. That makes sense. Maybe I could remember it that way.
like
In my brain, though, I want to see the ellipse and see how it's squished. My brain wants to look at the box.
Yeah.
if your brain is looking at the actual graph, which is a good thing, but my brain wants to look at the box. Whatever. So notice our focus has now moved back up here. Focus is still hovering inside. All right. C is still the distance from the center to the focus, which is great. The formula for C has changed. It's now addition instead of subtraction. Great, right? There are two other things I need you to write down. And so you should probably, I turned mine over to write it down, but maybe you can find some room. And these are the equations for the asymptotes that you see. There's one for each. So here are the equations for the asymptotes. These are the asymptotes for the left-right open. They are located at plus or minus. We'll have a y equals here a plus or minus b divided by a times x minus h plus k. Let me zoom in a little on that so you can see it. These are the asymptote equations. So the asymptote equations for these.
Wait, that's for left and right?
Yes, it matches what it's under.
I'm so sorry.
For
I'm
what?
gonna have to interrupt this. We really got what I didn't
Do you
know.
want to use mine?
I bought the dirty version of a game, of a math game, instead of the adult version or the children version.
I have the children's.
It's okay. I'm gonna go. I can't.
Oh, are you?
Look how bad these are.
Oh,
These are bad.
Oh,
I'm having a freak. I'm dying over here laughing.
these are the
Oh, what
math
are they?
Christmas
See?
party cards.
Yeah, like this. I could play this game with you and our other. I don't have a lot of smart friends.
We could play it later. We really should.
Sorry, I didn't mean to. What are we doing? Oh, Conics. I'm sorry.
Yeah. Oh no, look, she apologizes for us. All right, asymptotes for the up and down. This is cool because they're pretty similar. It's just a over b times x minus h plus k. So they're kind of the same. The only thing that's different is one has b over a, and one has a over b. So there are a lot of little patterns here. Okay, my gosh. Partially it's just because, why do we want to stay here for very long? All right, let's go back down and do a couple of examples here, or maybe a bunch of examples. The good news is you get 2 days to do this assignment too, just like you got yesterday. So.
It has it under late credit.
I can adjust it. I was messing with it this morning. I was gonna make it due tomorrow, and I was like,
Oh, this is okay.
Then I changed my mind, and maybe I didn't save it. All right, find the center of the hyperbola defined by this equation, and this should be pretty easy. This one's going to be 3, -6. This is kind of like still the same thing we have been doing, pulling out centers H and K. H always goes with the X, K always goes with the Y. So the center HK, nothing is different here. That came from here and here. Everybody with me on how I found the center? This is currently nothing really new than what we've been doing. All right, let's do this one. Let's find the vertices. And this is when I'll start rewriting. If you don't want to, you don't need to, then don't. But minus y minus 8 squared over 3 squared equals 1. So let's see which one we're looking at here. I've got a left-right open. I've got a left-right open, and so that means that I have a center and the vertices are to the left and right of the center. Y'all see how I know that? Yeah? Cool. All right, so the center for this one is going to be 4, 8. So which one of these is A and which one is B on the bottom? What?
5 is A.
5 is A. And which one is B? Obviously the other one, right? All right, so what letter describes the distance from the center to the vertices? A, so this would be center plus or minus A. All right, so this distance is 5. So again, we're kind of back like this is the same thing we've been doing. The only difference is we got to make sure that we're interpreting all of this stuff correctly. So if I'm doing that, I'm moving horizontally, so I'm going to work with this. So I'm going to subtract 5, and I'll have -1, 8. And then I'll add 5, and I'll have 9, 8. And so your vertices are -1, 8, and 9, 8. Okay, let's do another one. Now we're looking for co-vertices. What letter A or B describes the distance between the center and the co-vertices? B. This is the center plus or minus B, just like it was with the ellipse. So rewriting this would be y minus -9 squared over 5 squared minus x minus -9 squared over 4 squared. All right, so my center is going to be -9, -9. Is this a up, down, or left, right opening? Uh-oh. Which one? Up and down. Up and down. Up and down open. So I've got a center. That means I've got a center, and then I've got a vertex above and below. And I've got co-vertices. This is a vertex. This is a vertex. So remember, the co-vertices are located left and right. This is a co-vertex. Which one are we looking for? Vertices or co-vertices? And then we're going to determine that with the distance here. This is B. So that means that this distance is 4. And this distance is 4. From the center 9, 9. We're moving horizontally, so we will work with the x coordinate. So -9 minus 4. Maybe -13, -9, and then -9 plus 4 will give me -5, -9. And so those are your co-vertices. Cool. All right. Next one says, find the equations of the asymptotes of the hyperbola defined by this equation. We are looking for equations of asymptotes. So this will be x minus -7 squared over 4 squared minus y minus -8 squared over 9 squared equals 1. Is this a left, right, or up, down, open? This is left, right. And so let's go find the formulas for the left, right opening asymptotes. The left, right opening is going to be plus or minus b over a times x minus h plus k. Well, let's go over here and find these things. So what is a? 4. Remember, in the ellipse, A is larger. In the hyperbola, A is first. What's B? 9. Right? X minus H is just this right here. And then what's K? Right, now let's just go plug it all in. So you have two different asymptotes. We'll write the generalized stuff here. This is plus or minus. Y'all done, baby? Is there anything else you need? You good? I'll see you in third, okay? All right, so this would be plus or minus. We got B over A, so it's 9 over 4. Then we have X minus H, so that'd be X plus 7. And then we have negative 8, so that's minus 8. And there are the equations for your asymptotes. So you'll have one that's positive 9 over 4. And you'll have one that's negative. Negative 9 over 4x plus 7 minus 8. There we go. It already does the y equals for you, so you don't need that. What else we got here? Foci. Okay, buddy. Questions about asymptotes? Those are just the the diagonal lines that are kind of crisscrossing through that diagram. All right, let's do the foci. Remember, the foci are defined by what letter? C. Okay. So we're gonna have to find that for the hyperbola. Let's see. Let's write the center. We know we're going to need that. I'm going to skip a step here. So the center is going to be negative 9, negative 6. Remember, it's HK, and H always goes with X, right? All right, so what is A?
7.
What is B?
4.
Good. All right, so I think that's a good starting place for us. And so C for the hyperbola is defined as, C squared is equal to A squared plus B squared, which is just the Pythagorean theorem. So let's find C. That'll be C is equal to the square root of 7 squared plus 4 squared. It's going to be ugly, pretty sure. It'll be 7 squared plus 4 squared. Oh, that's stupid. Yes, 7 squared plus 4 squared. Square root of 65, is that what y'all got? All right, whatever. So C is the square root of 65. So let's go back to the diagram and you're like, all right, how can I find the coordinates of C? Well, C is just the distance from the center to the focus. So this is center plus or minus C. All right, is this a up and down open or a left and right open? Up and down. Which that makes, okay, I'm good with this. I get it now. I mean, Shane explained it that way. Like, it seems kind of obvious. I don't know where I was struggling with that. It's good now. All right, so this is an up and down open. So that means that my foci will be up and down. So this will be the center. And then I'll have a focus up here. This is the center, and then I'll have another focus down here. And if you're not sure, you can always just go back and put your eyes on it. So I said it was up and down open. I see the center. I see the focus is below and above. Oh, look, there's my staff picture. All right, so what defines that distance? We said that that is the distance C, which is root 65. So this would be root 65. We know our center coordinate is negative 9, negative 6. We are moving up and down from the center. So we're going to mess with which one, X or Y? Y. So we're going to find, negative 6 plus root 65 to go up for this focus. And we're going to do negative 65 minus root 65 for this one because we're going down. So you'll find when you do that that this is actually -9, and to the nearest tenth, that's 2.1. And on the bottom, -9, and then it'll be -14.1. So let me highlight these. So this is focus, and this is a focus. And together they make a foci. So -9, 2.1, -9. So you see, it's really just the same repetitive idea over and over and over and over with very small adjustments. So now it's the easy part. Now we'll graph the things. All right, so we need a center and an A and a B, and that's it. And of course, we need to know, is this up, down, left, or right?
Up, down.
Up, down. Up and down. So the center here is going to be -6. -6. A is going to be 3. What's B in this case?
One.
Yeah. Oh, y'all good. And so in your mind, you should think, if it's an up, down, open, that's center, and then you have a vertex and a vertex. So you should just be able to pull those points. You should be able to go locate your center at -6, 6. Or -6, -6. This is up, down, open. So is it ask you to pull the vertices? Like when it puts it on there for you?
Yeah.
You just have to pull the vertices. Okay. Okay, cool. So the distance to the vertices is A or B? A. So that's 3. And that's 3. It asks you to adjust the co-vertices as well, right?
Yeah.
And that's 1. And it'll just do the rest of it for you. You're really just adjusting that box. That's why my brain wants to see the box and not the. So you should have like this, this. And then you'll have this kind of bouncing off. This is all pulled over. That's why I don't like speaker car drawing by hand. One more graphing one. I'm going to give you the center and A and B. Is this left, right, up, down?
Left, right.
Left, right. Ooh, I can see it now too. Sweet. The center is 6, 4. A is 3, B is 1. So remember, your A is going to be left this way and this way now. And this will be 1, and this will be 1. Because this is a vertex, this is a vertex. This is co-vertex and co-vertex because it's oriented a little different. So you'll just graph the center, you'll drag A and B to those appropriate locations, and you'll be done with that. And writing the equations is just as simple as it was last time. All right. Writing the equation of this, well, we really only need the center and A and B to know which one, right? This is an up, down, open. So, you'll come right y minus k squared over a squared. This is the general form. X minus h squared over b squared. And really all you need is h and k, a and b. And if you can get those things, then you're kind of done. The center is -2, -4. That's right here. So what's A? Look at your formula sheet. Is it 3 and 2?
It's 2.
It's 2 because remember what I said, it doesn't matter if it's bigger or smaller anymore. A is the distance to the vertices. This is a vertex, and so A is 2. And the distance to the co-vertex is B, so B is 3. And then you just plug it all in there. That's what I mean when I say they hurt my head, because I'm like, so this would be y minus -2, so that's +2, over a squared, which is 4, minus x minus -4. No, wait, I did it backwards. This should be 4. Because remember, this is h and this is k, so this would be, I want to be sure. Yeah, this would be backwards, +2. Y'all see why I did that? Maybe that didn't trip y'all up, but it did me. Because I need this as h, I need this as k.
Did you mean to put the square on the 9?
Nope. I was thinking about my h and my k. Here we go. That's right, one more. This is another up, down, open. Center is -1, -1. What's A? 7. What's B? 4. I mean, and now we're just going to put it in. This is H. This is K. What would it be? Let's try to do it. Y plus 1 squared minus x plus 1 squared 49, 60. Beautiful. I think the reason I struggle with the open up concerning the y is because with the parabola to open up, like normal parabolas are x squared. My brain doing the most. We have still got, you've got a little time to work today. Let me adjust the due dates on Delta so it's not showing a late date. This one will be due not tomorrow, but the next day. What is due tomorrow?
We did yesterday.
What we did yesterday and your quiz correction. So, okay. That's all for me.